Welcome back, aliens. My name is Navin Reddy, and in this video, we'll talk about Stream API. In fact, in the earlier video, we have talked about for each, and I hope you got some understanding of how to use for each. And in this video as well, somewhere we'll talk about it. But important topic for this video is Stream API. Now think about this. When you talk about collection, so why do we use collection in Java? To store data, right? Of course, if you have a lot of data, you can store that in a collection. It can be normal primitive values. In fact, in collection, we don't save primitive value. We save the integers or float or double in the format of their classes, right? Or the objects. So basically, we have wrapper classes. So let's say if you want to store numbers, if you want to store string, of course, you can mix data, but let's be very specific to data here. It can be integers, numbers, or it can be complex objects. Let's say I want to create a collection of laptops, which will have laptop ID, laptop name, or something like that. The idea here is in the collection, you can store data. Now, sometimes you want to process that data. So how do you process data? Of course, you can use a normal for loop, or you can use external for loop, or you can use for each to get the data and you can print. The only thing is, sometimes you need to process the data in terms of changing values. Sometimes you have to change data in terms of filtering the values. And then sometimes you need to reduce the value. So there is an option of Stream API here, which creates a stream of the values which you have, and then you can do the operations. I know a lot of things are looking theoretical now, but let me just jump to the code here itself. So in the last example, we have done this, right? We have list of values, and I can perform some operations on it. So what I can do is, at this point, let me just remove this extra code from here. Now, if you have not seen the earlier video, don't worry. What you have is you have a list here which has some values, which is, let's say, 5 integer values. And then I was able to print them with the help of for each. Now what I will do is, I will perform an operation where I want to map this value and double it. So example, whatever value I have here, example 4, I want to make it 8. Okay, so I don't want to change the existing list because that will make it immutable. Normally, when you want to work with a lot of data and when you want to use multiple threads, it's always better to have immutable data, which means don't change the existing value. If you want to process, you can do it in a new stream. Okay, what I'm saying is, whatever I do with the values will not affect my list. As simple as that. So what I can do is, I can create a stream here of values and I want to print the double of it. So I want to say 8, 10, 14, 16, and 18. So the way you can do that is you can create a stream out of it. Now, how do we do that? It's very simple. You can say nums dot. You can see we get different methods here. We have talked about for each, and if you are familiar with collection API, you might be knowing add, get, and all those methods. But in Java 8, we got this concept called stream, and you can use this stream. And if you observe, when I typed stream here, see if I say stream, we get one more option of parallel stream. That's right. So if you have huge amount of data and if you want to do the processing using multiple threads, you can do that. And the beauty is you don't even have to create the threads by yourself. Java will handle for you. At this point, I don't want to use parallel stream. Let's go with the stream. And what this stream will do. So if I jump to the stream method, which is there in the collection, you can see it's in collection. The stream method returns you a stream. Okay, that's weird, right? So this is a method. This is a type. Okay, so if I jump here, this is basically an interface. Stream, which is extending base stream, which has a lot of methods to work with. At this point, we want to use one of the method. And if you remember, at the start of the video, I mentioned we want to change the values, right? So I want to make 4, 8, I want to make 5, 10. So that can be done with the help of map. See, looking at the syntax, things look difficult. Let me just simplify that for you. I will go to demo.java, and here I want to create a stream. That's done. But then when you call this stream, it will return you the stream of values. So what I will do is I will store that in a stream which has integers. And mind you, you can also use different complex data here, not just normal values. Okay, maybe I have to import the package. Yes. And then I want to give a name to it as well. So I will say this is my data. Of course, you can call it anything, but I'm saying data. So basically, when you call this method stream, it will return you the stream of values. And that's what we are storing in data. Now with this data, of course, instead of printing nums now, I can print data as well. So you can see I got this stream, which is data here. And on this data, I'm using a for each method. So what this for each will do is it will pick up the data from stream one by one and it will print. That's what we are doing here, just printing the data. Okay. And if you still want to understand this in a proper way, you can watch the earlier video of for each. This will make much more sense. And now after doing that, let me just run this code. You can see we got the same values, right? So then you will say, hey, what's the advantage of using stream here? See, the thing is, we are not working with the existing list. We got a stream here on which you are performing the operation. Now, in future, even if you change the values of the stream, it will not affect the list. That's one. The second one is, once you use the stream, which means once you consume the stream, you can't reuse it. Okay, I will show you that in some time. And by the name stream, what it means, stream of data, right? When you have multiple data, like we have the flow of water, stream of values, right? Okay, so what I was saying is once you consume the stream, you can't reuse it. Let me show you the proof. What I will do is, see, at this point, the stream has been used, right? It has been consumed. And if I try to do this once more, okay, I'm doing the same thing again. I'm using the same data for each. And the moment I run this code, it will first print the first stream. You can see this line has no issue. Line number 14 is working. But the moment I run the line number 15, this is what it says. It says exception because of this. Stream has already been operated upon or closed. That's why the moment you use stream once, you can't reuse it. And that's the beauty. See, for the beginners and if you are learning for this for the first time, it will not make any sense why you have to close something when you can use it multiple times. But when you work on the project, when you have huge amount of data, it's always better to work on the data and close it so that you will not get data leakage or you will not have some unused resources open. Okay, so this will not work. So point to remember, you can use the stream only once. Okay. The next thing we want to do here is I want to perform the operation, which is I want to map these values. The way you can do that is, in fact, before that, I just want to check, do we have any other method which we can use at this point? You can see we have for each. We also have count. Okay, so what count will give you is the size of your stream. Should we try this first? Let's try. So I'm saying count now. And again, once you use a stream, at this point, when I say data.count, the stream has been consumed or it has been operated on. And if I can store that in a long variable, long, I will say count itself. So long count equal to data.count, it will store the values, the size of your stream. And basically you can print it as well. You can print the count. So you can see if I print count here, this will work. Okay, so we are printing the count value as well. And what do you think now? Let me know in the comment section. If I run this code, will it work properly? Of course, it will print the count, but what do you think? It will work perfectly or you will get an exception? Let's try. So let's run this code and you can see we got the value 5, which is the count. And also we got the exception, the same exception. Why? Is because at this point, the stream has been consumed. And here, we are trying to consume the stream once again and it will not work. Makes sense, right? And now, of course, this will not work. So I can just simply comment this part. So you can see we got a count and this is working. Apart from this, we have multiple methods, right? So let's not use this now. We don't want to use count. I can simply go with data dot. What other methods we have? We can use count. We can use map. Find first. You can also apply the filter to find first and those things. Just to keep it simple. Okay, we also got sorted here, which will sort the values for you. And you can see this sorted actually returns a value. Sorted returns a new stream. Okay, so that means if I run this sort, it will basically create a new stream. And I can say stream of integers. And of course, I have to give a different name. Or maybe I can use the same variable that works. But let me just have a different value. So I can say sorted data. Now this data is a stream. Okay, so you can say this is another stream and this is a new stream. Now, yes, the earlier stream has been consumed here, but you can use the new stream here. So what I can do is I can print this value, but again, I can't use data. As you can see, if I run this code, it will say the stream has already been consumed or operated on. So we have to work with the new stream, which is sorted data. So this is the new stream which we can act upon. And if I run this code, you can see it will sort the value. And the beauty is the values were already sorted. Okay. So let's say 6 and let's say 2. Let's say 8 is good, and this is, let's say, 1. Okay, so now I want to sort this. If I run this code, and you can see we got sorted values. So stream provides a lot of different methods to work on that data. You can sort the values, you can print the values, but then we want to do one important thing, right, which we talked about. We want to double the values and print. So what I will do is, even before I use a stream, let's try this with normal loop. How do you double a value and print? So what you do is you use a normal for loop, or maybe you can use the enhanced for loop. So I can say int n colon, and I can fetch the value from num. And then once you get the value, you can simply double the value and print. I can create a new list to store the values, or I can just print it here itself. It makes sense to create a new list and do that. And if I run this code, you can say it will double the value and print. That is working. But again, this is the external loop and you are working on the data. So better than this, in Stream API, we got another option. I will comment this part and go back to my stream. And I don't want to use sorted data anymore. Let me just work with the data itself. But what I want to do is, on this data, I want to double the values. So the way you can do that is by saying data dot. So you can see we have a method here called map. Okay, and if I say map, you can simply pass the value here and you can perform the operation, whatever operation you want to perform. Maybe you want to double the value, maybe you want to subtract the value. So whatever operation you want, you can do. Map will simply say, hey, I will give you the value. You tell me what to do with that value. So what I want to do is I want to double the value, right? So it will simply give the value. I can store that value in n, and then on that n, what you want to do, I want to double it. That's it. This is your map. And even map, if you can go to map, map itself gives you a new stream. So what I can do is I can say stream integer, and I can say mapped data. So map data equal to data dot map, and we are performing an operation. So at this point, this is your new stream. So what I will do is I will just print the new stream. I will say mapped data, and then I'm saying for each. Let's run this code, and you can see we got double the values. Again, the same thing which we have done here, but if you can see, this logic makes much more sense. So when you read the code, you will actually understand what is happening, right? Of course, you need to get used to Lambda expression and Stream API, but once you are used to it, you can actually read, okay, so at this point, we are getting a new stream. We are mapping the values, we are doubling it, and then we are printing it, right? You know what the beauty is? At this point, this is a new stream, right? So we know that nums.stream actually creates a stream, and then on that stream, you are applying map, right? So can we do this? I will say stream dot map here itself, and I will say n and n into 2. So basically what I'm doing is, whatever we are doing on this line is now already done on the upper line. Done. So we can do that in one line. And we can also run this for each. I will just cut this part and paste it here. So you can do everything on the same line. The only thing is, when you are printing the value here itself, because see, for each will not return the value, right? So this will not work now. So even why do we have to use a stream now? I mean, why we have to even refer that when you can directly print it? So what I'm doing is, I got the nums, which is a list. On that list, I'm applying a stream operation which says create a stream for me. On that new stream, I'm applying a map which will double the values, and it will create a new stream. And on that new stream, we are running a for each. So this is, if you know design patterns, this is something called builder pattern, where you build a new stream with everything. And one of the best way to write this is, you can say nums.stream. I mean, just for the visual representation, you can just say dot a new line. It makes it much more readable. So you got a new stream from this list, and then you are applying a map, and then you are printing it. This makes sense, right? And now if you run this code, you can see we got the same value. In fact, you can do one more thing. Before mapping, you can actually say sorted. So what we're doing is, okay, first of all, let me know in the comment section with the timestamp how many streams we are creating with this code. Let me know in the chat window, also in the comment section. So let me give you the answer. This is where we are getting a stream. So one stream, second stream, third stream. So in total, we got 3 streams here with this 3 lines. Now you'll be saying, hey, we are wasting so much of memory. Not exactly. The moment you completed the first stream, it is gone now, right? You got a new stream. So basically we are replacing, we are not duplicating it. So this is how it works. You can see we got the values, it is in sorted format. In fact, you can do one more thing. Maybe you don't want to double all the values. You just want to double, or maybe you just want to sort the values which are odd numbers. How many odd numbers we have here? We got 1 and 2. Let me just add one more odd number here, which is 7. So I want to perform this operation. So at this point, if I run, it will apply on all the values. I want to do this only on, let's say, odd numbers. So what you can do is, before the sort itself, you can say dot, and there's an option called filter. At this point, if it is confusing you what this map is doing, how exactly it takes the value and perform the operation, we'll see that in some time, or maybe in the other video. So in this filter, what filter will do is, filter will take the value from you. Example, it will say n, whatever value you want to pass, and then on that n, on that filter n, whichever value it will pass, we have to apply the filter. Now, how do you filter? So I want to filter based on the even odd values. So I want to perform this operation only when the value is odd. So when you create a new stream, we can pass the values which are only odd numbers. Okay, makes sense. So now what we do is, we have to say, I want to filter based on 2 equal to 1. So if they are odd numbers, this is how you find even odd, right? So this is how you find the odd number. If this is true, it will pass the value ahead. It will say sort, and it will say map, it will say for each. And now if you're in this code, you can see we are only finding, so we got 2 because we got 1 here. Double the value of 1 is 2. Then we got 5, 10, and then we got 7, 14. This is working. Now I know you have this confusion how all these methods are working. Okay, for this, let's do in detail. So let's work with one by one. Let's talk about filter. Now when you talk about filter, if you jump to filter, what filter does? Filter has this type, or it takes an object of predicate. Now what is a predicate? So predicate is a functional interface which has a method called test, and this test returns true or false, right? Don't you think that's what we are doing here? This will return true or false, and we are filtering based on that. But what if you don't want to use lambda expression? What if you want to use a object of predicate? So let me help you with that. So what I will do is, I will create an object of predicate. So I will say predicate, and predicate will be applicable on integers. And here I will say, let's say test itself, or I can say predi equal to, and then I can create the object of it. I can say new predicate, but this predicate has a method called test, if you can see. And we have seen that, right? In predicate, we have this test method. So what we are doing is, we are creating an anonymous inner class. And in this, you can pass a value. So let's say if I say n, instead of integer, let's say n. And based on the test you want to do. So what test I want to do? I want to test this. If this n mod 2 is equal to 0, in this case, return, in fact, I want to test for odd numbers, right? 1, in this case, return true. Otherwise, it will return false. I can say else, return false. Okay, this works. So basically, you can see I'm creating an object of predicate here. Basically, I'm trying to instantiate it with the help of anonymous inner class, which is this. And then we have set the condition as well. And we know that filter takes an object of a predicate. So I can simply say predi. This works. Let me just run this code. And you can see we got the same output. Now what I do is, we have seen lambda expression, right? And we know that when you have a functional interface and when you have this syntax here, from here to here, it's of no use. And we can also remove this curly brackets here. So we can remove the outer curly brackets. Let's do that. Remove. Okay, that's done. In fact, before removing, I want to do one more thing. I wanted to show you one more thing, which is, don't you think instead of using if else, I can simply say return n mod 2 equal to 1. See, this itself returns you a true and false value, right? Because this is double equal to. And then this method just returns a Boolean value. So why we have to even write the true and false? Okay, number of lines have been saved. Okay. And now I can literally remove this part. So remove this part from till here to here. In fact, not there, till this point. And remove this curly brackets as well. And then we have talked about it. We just have to put an arrow here. Again, lambda expression, nothing new. One more thing, when you have only one statement, you don't need to put curly brackets. Let's remove that. If you have only one statement, and even that one statement is return, then you don't have to put, or you don't need return there. It will give you, anyway, it will give you error. So we don't have to put return, you can remove return. And also, this integer type is optional. So you can remove that. And this round brackets are also optional. You can remove that. So you can see from this big chunk of code, we were able to remove everything because of lambda expression. And again, I have made a video on this. You can just go back to the previous video and watch. And now, so you can see whenever you have predi, can you put this code instead of predi here? You can, right? If you can use, if A is equal to B, whenever you have A, you can use B there, right? So that's for filter. Can we do it for map? For map also, we can do the same thing. But I want you to try that on your machine. So go to map and find which method, what type of object it takes. You can say it takes function. And if I go to function, function is again a function interface, lambda expression, we can use it. And we have only one method called apply, right? So we can use that. And try this out and let me know in the comment section you are able to do that or not, so that I can make another video. Now, before I conclude with this video, I want to do one more thing. What if I don't want to print the values? You can see we got 2, 10, 14. What I want to do is I want to add all these values and print. So example, it should be 2 plus 12 and 14 is 26. So I want the output to be 26, not individual values. So basically what you're doing is you got the values, you applied the filter, then you tried to map the values, and then now you want to reduce. Now, by any chance, if you're coming from the world of big data, we have this concept of map reduce there, which filters the data, which maps the data and create a reduce part of it. So we are trying to do the same thing here. So instead of for each which prints the value, can we just reduce the value? And that's right, we have this method called reduce, if you can see. Now see, whenever you add 3 values, how do you do it? So let's say if I give you 3 values, 2, 10, and 14, in your mind, how will you do it? Think about this. So if you got 3 values, first of all, you will add the first 2 values. You will say, okay, 2 plus 10 is 12. And then the output of the first addition will be added with the last value, which is 14. So you will say 2 plus 10 is 12, 12 plus 14 is 26, right? The same thing we have to do here. But the only thing is when I'm saying we have to do this repeatedly, so can I say, instead of adding 2 plus 10 initially, can I say 0 plus 2 is 2, then 2 plus 10 is 12, then 12 plus 14 is 26. So at the start, we have to start with 0. So I can say for any value n, take the value and perform the operation. I don't know why I forgot the syntax. Is it? Okay, I literally forgot the syntax of reduce. What I will do is, and that's part of normal Java life. If I go to reduce, reduce takes how many parameters? It takes an object, it takes two parameters. First, it takes the value, okay, which is t. In fact, I will jump to this method here. So you can see it takes 2 values. One is the value itself, and second, it takes the object of binary operator, okay, which means basically first you have to pass the value n, and then we have to take the object. Okay, this binary takes a value. Okay, I guess it is by function. Yeah, so there is an apply method which takes 2 values. So basically we have to start with 0, and then it takes 2 values. One is, let's say, I will say C comma E, and then I will perform the operation which is C plus E. Now you will be saying, why this named C and E? Remember when we do basic mathematics, when you add 2 values, so example, if I say the 2 values are 99 plus 88. So what you normally do is you say 99 plus 88. And then you try to add this value, you say 9 plus 8 is 17. So you will write 7 here. And then 1 will be carried here, right? So you say carry. Oh, basic maths, I love it. So in the same way you can say this is E is element, whatever element you are passing. Example, when you say 2 plus 10, so this is 2. This is 10, and you can add those values here. And this 0 is basically a starting value from where you want to start. And I just hope this will work. Now, the only thing is with this reduce, if you can see, it returns a value. So basically here, I need to accept the value. I would say int result is equal to. So whatever basically you're reducing, it will return the value. And then the same value, I can print it here. It's that simple. Let's run this code, and you got 26. So the question is, what is this 0? Remember, as I mentioned, when you add these 3 values, which is 2, 10, 14, initially you will say 2 plus 0. So that is that 0 here. And then whatever the output of the first operation will be C, which is the carry and the new element. So when I say 2 plus 10, which is 12, so 12 is C now, and E is your new value. And that's how we can use Stream API. In fact, you can also use parallel stream. The only thing is, sometimes your values are dependent on the earlier operation. In that case, don't use parallel stream because it will do the operation parallelly. At this point, I guess this sorted is only the blockage. Example, if I use parallel stream here, I think it will create an issue because of the sorted here. Let's try. Okay, it's not getting an issue. Anyway, why do we even need sorted here? So if I run this code now, I don't know if it is faster or not, but parallel stream basically use multiple threads to do this. So it all depends upon what type of data you have, what type of operation you want to perform. Parallel stream will make sense. So yeah, that's it from this video. I hope you enjoyed about Stream API, which is a new include in Java 8. And if you want more such videos on Stream API features, let me know in the comment section. And do subscribe for further videos. Bye-bye, everyone.